Okay, so for our last lesson for the second quarter, we have here kites. Okay, so good day, grade 8 Makati Science High School students. This is our last lesson. Okay, so we have here kites. So you normally see kites, guys. Pre-COVID, we saw kites outside. Okay, a lot of kites, and also we also see kites virtually. Right now, as you can see here the pictures. But if you ever flown a kite when you were young, or also right now, if you've been flying a kite, if you were allowed to go outside, so that's really nice if you had that experience. And if maybe you haven't yet flown a kite, have you tried making one? Making a kite, so that's nice if you've also made a kite. Okay, so there are different designs of kites. So most often they're kind of like shaped like a diamond. Okay, so we have here like a small triangle here at top, and then a very peaked or slopey triangle here at the bottom. Okay, and therefore we create a kite that's diamond shape. Okay, and we have here some of the examples. Most of the kites that we see are very colorful, and if you ever try to visit what do you call this, Bacolod City. So Bacolod City annually hosts the kite festival here in the Philippines. So Bacolod City, and for last year it was on Sipalay City, or was it on 2019? Okay, so March 2019. Okay, so before COVID, so there were a lot of beautiful kites that flown in the skies of Sipalay City and also in Bacolod City during the annual kite festival. So as you can see, the kites are not just diamond shaped. They can be in a shape of a bird. They can be in a shape of like this fish here. It's kind of like a fish. Okay, so there are so many shapes that you can create with kites. But for the subject geometry, for the purpose of studying geometry, we'll focus on the convex kite. Okay, so we'll focus on the convex kite. So we have here, guys, the two types of kites. Okay, so we have here a convex kite and a concave kite. So the convex kite is signified by this quadrilateral. We have here STAY, stay. Okay, so we have here it's a convex kite because if you notice, the one of its one of its points is jutting outwards. Okay, so that's how you can tell that a kite is convex. If one of its points or endpoints are endpoints or vertices are extending or are jutting outwards, while the concave kite, it's caved in. Okay, so from the word concave, so the one of the points are, of course, it's not jutting outward, it's caved in. So let's say, for example, we have here the concave kite, MURP. Okay, so kite MERP. Okay, so I've never seen this type of kite before. So have you seen this type of kite before, guys? So if you've seen that, so that's really cool. It looks like an airplane, like a paper airplane that's been like created into this cool looking kite. Okay, it's kind of looks like a symbol for a cool company. Okay, so we have here, guys, the properties of kites. We've already discussed this in our topic quadrilaterals during the first quarter, so we've discussed this. So let's just do a review. And again, guys, we're not going to be discussing the colorful and irregular shaped kites that we see on annual kite festivals, but we're going to study the foundation of kites, the convex kites. Okay, so for the convex kites, so it has two distinct pairs of adjacent and congruent sides. Okay, so let's say, for example, we have here kite KITE. Okay, so we can say that KI is congruent to IT, and KE is congruent to ET. And the diagonals of the kite are perpendicular. So IG is perpendicular to KT, and one pair of congruent and opposite angles. Okay, so we have here angles K and angle T are congruent, and then we also have one pair of congruent opposite angles. One pair of isosceles triangles are also found in a kite. Okay, so if you see here the diagonal here at the center, okay, so the diagonal separates two isosceles triangles IKE and ITE. And also we have one diagonal forming two isosceles triangles, as mentioned a while ago, and one diagonal bisects the other diagonal. So it's usually the longer diagonal that bisects the shorter diagonal. So if we have here a diagonal of KT, so it is bisected by this line segment IE, okay, on the kite. So that means if we have here a point, okay, so let's say we have a point O here at the center, then we can say that line segment KO is congruent to line segment KT. And one of the diagonals of a kite is perpendicular, okay, as we've said on number 2, the diagonals are perpendicular to each other. So therefore, one of the diagonals of a kite is a perpendicular bisector. So there you go. We've combined the concept of a bisector and a perpendicular of two pairs of perpendicular lines. Okay, so let's try to prove some theorems here. So we have here the first proof: if a quadrilateral is a kite, then it has one pair of opposite and congruent angles. As with all proofs, we start with a given. So let's start with our given here. We have here kite, KIT. Okay, KIT. Okay, and we need to prove, okay, for this specific problem, we need to prove that IE is congruent to angle I is congruent to angle E. Okay, so angle I is congruent to angle E, but angle K is not congruent to angle T, because in a kite, there's only one pair of congruent opposite angles. Okay, so for number 1, we have your kite, and that's a given. Okay, so what do you think, guys, can be the second statement for this proof? Okay, so let's see. Okay, number 2. Okay, so we can write here, guys, okay? We can write here that KI, okay, let's write that. So KI is congruent to KE. And also we have here IT is congruent to ET. So the reason for that is simply one of the properties that we have seen about kites. Okay, so we can write here that the adjacent sides, the pairs of adjacent sides of a kite are congruent. Okay, so let's try the third one. Let's try the third statement. Okay, maybe we have to prove first that angle I is congruent to angle E. We can try to prove that first. Okay, so in order to do that, we need to establish that we have two triangles that are congruent. So we can try triangles KIT and KET. Okay, so let's try to focus on those two triangles. So we can say here, okay, we can say here that KT, okay, I'm sorry, let's write that neatly. So we have here KT is congruent to KT. So KT is congruent to KT. So the reason for that is simply reflexive property of congruence. Okay, or KT is congruent to itself. Okay, so let's write number 4. Okay, so what can be our fourth statement here? So, we've already stated that this side is congruent to this side, and this side is congruent to this side, and KT is congruent to itself. Therefore, we can now say here on our fourth statement that triangles, okay, let's write that much more nicely. Triangles KIT and KET are congruent. Okay, so how are they congruent? We have three sides of both of those triangles being congruent to each other, so we can say here that they are congruent using the SSS, or the side triangle congruence postulate. Okay, so let's let's try now the fifth statement. So what can we say here on our fifth statement? Since we've established that the two triangles are already congruent, therefore we can say their corresponding parts, that includes their sides and their angles, are also congruent. So we can say here that angles I and E are congruent using CPCTC, or congruent parts of congruent triangles are congruent. Okay, and we've already proven angle I is congruent to angle E, but we need to also prove that angle K is not congruent, is incongruent. Okay, so it's not congruent to angle T. So how do we do that? Let's try to make an assumption first. Let's assume first that angles K and T are congruent. Okay, so we're going to prove this using through contradiction, or we're going to use a contradiction to our proof, so we can state the other or the converse statement, or the opposite of the statement that we want. Okay, which is angle K is not congruent to angle T. But first, let's establish, or let's assume that angles K and T are congruent. So we can write here as a reason. Okay, so that can be an assumption. Okay, so that can be an assumption by contradiction. So we want to contradict that. Okay, so if angles K and T are congruent, then we have now two pairs of congruent angles. So if we have two pairs of congruent angles, we won't have a kite anymore. We're going to have a parallelogram. So therefore, in number 7, KITE is not a kite anymore. It becomes a parallelogram. Is a parallelogram. Okay, so the reason for that is a parallelogram has two pairs of congruent opposite angles. Okay, but KITE, the kite, is not a parallelogram. It's a kite. Okay, so we've contradicted our given there, that KITE is a kite. It's not a parallelogram. So therefore, the assumption that angles K and T are congruent is not true. We can say here at number 8, okay, we can say here on our 8th statement, okay, number 8, that angles K and T are not congruent, because that will be a contradiction to our given. Okay, so the reason for that is a contradiction to the given information. And there we go. So we've already proven that angles I and E are congruent to each other, and angles K and T are not congruent to each other. Therefore, we have here a quadrilateral, which is a kite that has one pair of opposite congruent angles. Okay, for our next proof, this is going to be an easy one. If a quadrilateral is a kite, then it has one diagonal that forms two isosceles triangles. So we have here kite LING. Okay, so we want to prove that triangles ILN and GLN are congruent. Okay, and also they are isosceles triangles. So we can write here for our given. Okay, number 1, we have our kite LING, and the simple reason for that is simply given. And number 2, okay, our second statement could be, since we're proving ILN and GLN, we can go right ahead with this side. Okay, so we can say here, since reflexive property of equality is our best friend when we're doing two-column proofs, we can write here that LN is congruent to LN. And the reason for that is, okay, so there is a lot of uses for this property, reflexive property of congruence. And we can also, of course, use transitive and substitution property of equality, but a reflexive property of congruence is your to-go proof if you're like getting lost in your theorems, okay, and your proof. Okay, so we can write here for number 3. Okay, so what else can we say? So going back to the properties of kites, we can say that IL is congruent to LG, and IN is congruent to GN. And the simple reason for that is the adjacent sides, or the pairs of adjacent sides of any kite of a kite are congruent. Okay, and then lastly, now we can say that those two triangles are congruent using the SSS, or the side-side-side triangle congruence postulate. So triangles ILN and GLN are congruent using SSS, or side-side-side triangle Congruence, Postulate.